Welcome to Embedded. I'm Elecia White. My co-host is Christopher White. As you know, I like robots and have some computer vision plans. Also, as you probably know, the whole podcast is just a front for me to ask people impertinent questions about their projects, especially those projects that are similar to the ones I'm working on. Please don't tell our guest who is Kwabena Agyeman, because I am excited to have him on the show and wouldn't want to ruin the surprise. He's sitting right here, by the way. So, before we get started, in last week's show with Dennis Jackson on how to get into embedded software as a career, we mentioned my book, Making Embedded Systems. One of the things I liked writing best was the interview questions at the end of each chapter, where I talk about what you look for in answers to embedded software interview questions. And we didn't talk about that last week, but I wanted to mention it because it was so fun to do.
Hi, Kwabena. Thanks for joining us on this side of the hill.
Thank you very much for having me.
Could you tell us a bit about yourself?
Well, went to Carnegie Mellon University, got a degree in electrical and computer engineering, got into electronics back in ninth grade with Forrest M's the third kit from Radio Shack. I don't know, you can call me an engineer's engineer. I love understanding things and getting into the technical details. I started working on OpenMV, which is what I'm here today doing this radio interview for, as a solution to being able to give a robot or any other embedded system vision in an easy-to-use format.
And of course, we have many questions about that.
Mm-hmm.
But before we ask them, we're going to do lightning round, where we want you to answer short questions with short answers. And if we are behaving ourselves, we won't ask you why and how and all of the questions that will come up inevitably.
And it never works.
Mm-hmm.
All right. Verilog or VHDL?
Verilog.
Favorite movie or book or any sort of fiction that you encountered for the first time in the last 12 months?
Cloud Atlas. Just watched that last night on Netflix.
All right.
Amazing they had a good movie on there.
Favorite man-made space object?
I would have to say Planet Labs doves.
All right. Well, that was kind of cheating. Little or big Endian?
Little Indian.
Beach or forest?
Beach. I grew up in Miami.
Excellent. That was just a question to ask you which one we should direct you to when we're done here.
Okay. Got it.
Preferred voltage?
Preferred voltage, 3.3 volts.
Favorite animal?
Favorite animal, barracuda. That's not an animal, though.
Well, sure it is.
Okay.
It's not a plant.
Yeah, well, it's a fish.
Technical tip everyone should know.
Don't reverse power and ground. It's a surprising issue. Surprising issue with people.
Well, every board I get or have gotten historically has had that switched. Do you like to complete one project or start a dozen?
Complete one project.
You mentioned Planet Labs and the doves, which image the Earth regularly. What's your favorite region of the planet to look at with that imagery?
You know, I haven't really had time to do that, but I saw the most crazy images over the United Arab Emirates. They've got a Ferrari World out there.
Ferrari World?
Yes, Ferrari World.
I like to believe it's in the shape of a Ferrari that you can see from space.
It's even better.
We're going to have to look that up.
Yes, definitely look at it. It is some crazy stuff. Anyway.
Okay, so on to the topic of the show, OpenMV and computer vision. You mentioned that OpenMV is a controller and makes computer vision simpler. Could you give us more information?
Okay, so the basic idea behind the OpenMV Cam is to more or less give you an environment where you can write the most minimal amount of code to get the biggest result. An example would be, would you like to build a fully fledged line-following robot with only 92 lines of code that you can copy and paste like an Arduino script? The OpenMV Cam can kind of let you do stuff like that. Pretty much If we look a little bit back in time, part of the reason why the Arduino is so popular, well, starting to get kind of, it's fighting with the Raspberry Pi right now, but one really big thing that made it really nice to use was it had a very simple editing environment where you focused on one file and you put all your code in that file, and you could then get something working with just the code in that file, and there wasn't you fighting with different tools or opening different files or so on and so forth. And of course, this has its limitations as the project gets bigger. But if your goal is just to get something really simple and really quick going, or if you're a student in a class, it's kind of the most optimal development solution that's not dumbing it down to the point of like Scratch where you're dragging blocks around. And so the OpenMVCam tries to mimic that a little bit, but with Python instead of C, and the ability to actually use computer vision algorithms. In particular, we do stuff like, so there's a library called ZBar, which will detect barcodes. It can detect all these different types of barcodes, 16 total, in fact, more barcodes than you thought there actually existed in the world of barcodes. And library is a giant mess of code, lots of things to understand and see, very not super easy to interface to. So we wrap all that up into a simple function called find barcodes. You can call an image in Python. And you do that, you point the camera at a barcode, and it then returns to you a string that tells you what the barcode number is. It's so easy, you can't fail. We have similar things for like detecting QR codes and detecting data matrices, which are a barcode you probably haven't heard of, but it's on your mail. Anyway, but the OpenMVCam was kind of built to wrap up very, very complicated computer vision task into a simple one line of code function call, and then to be able to let you take that output and do filtering of objects in Python to basically to get your robot to do something or get some kind of mechanical system to do something, but then really have a programming environment where you're just working on one file, so you don't really have to go off and start a huge project of lots of different compile options or so on and so forth. You just have one nice Python file that contains your program, and using that, you can build your application. Sorry, that was a long-winded.
No,
that's very good.
That's good. So it's Python, but it is an embedded system. And it's more than a smart camera. It's a controller. The heart of this is a Cortex M4F?
No, we actually upgraded to an M7 now.
Oh, okay.
Oh, wow.
And so it's really important to understand the Cortex M7, if you look at its performance numbers, it's really a Pentium 2 processor. A Pentium 2 processor, by the way, those are the same kind of CPUs that were built into the original B-2 bombers, those super ultra stealth looking planes that carry nuclear bombs and whatnot. That's the same processor. So we've got, equivalent performance from back in the 90s, whatever. But on this little platform, it's actually about half as strong as the Raspberry Pi Zero in terms of compute power. But one thing to keep in mind is, since its RAM is all on board the chip, it never has to go off memory to access DRAM. And the big thing to keep in mind here is that it's got a 200 megahertz plus bus that's 256 bits internally to access its internal SRAM. And so that actually gives you about 50 gigabits a second or so of just raw performance to access memory. And this means it can actually do vision algorithms at pretty high speeds.
Okay, a Pentium 2 with super fast RAM, and you use that to do vision algorithms. And you mentioned line following. Yes.
So the one thing that's good to do that I'm doing now with the system, I'm working with Chris Anderson with the DIY Robocar Challenge. So basically, we're building, right now at least, line following robots, but they're based on go-karts. Well, not go-karts. RC cars. And so these guys are moving at about, 1 or 2 miles an hour. So they're not going slow anymore. And we want to get those things going up to around 5 miles an hour or so. Of course, these are all to scale.
Right.
This is a 1/16th car. So if you blew that up into how fast it was actually going, it'd be driving faster than a person down the road. But The idea is to race them really fast around tracks. And once everyone's mastered the ability to follow a line, we want to start adding things like, okay, now there's intersections. Now there's other cars on the road. Can you avoid other people while following the line? Can you merge or other things like that? Anyway, it's just in the beginning right now, but our system, OpenMVCam at least, lets you easily build that line following robot. I've got an example I'm putting up online that more or less is kind of, an instructable. Copy and paste some code, buy all these parts, wire it up correctly, and bam, you got a line following robot that can, follow a line outdoors, down the road, outside your house, whatever. Anyway, you asked me about algorithms. So the algorithm that we use to follow a line is something called linear regression. It's not particularly challenging, but there are two different types of linear regression. One is called regular least squares, and that's one a lot of people learn about. If you took a statistics class, they probably had you have to do that back in college by hand. And there's another one called robust linear regression. There's another class of linear regression techniques. So least squares has a problem in that if there's any single pixel is outlier, it immediately draws the line through that outlier instead of all the other pixels that look like a line. Whereas robust linear regression will do something that requires an n-squared type of algorithm where it wants to find the slope between all pixels, and then it kind of finds the median of those slopes. And this lets the system act kind of like how a human would think. If you give a human a picture of some lines, things in an image, the robot will basically draw a line through that just like a person would. And so using that then, you can take the output of where that line is and then drive your motors to keep the robot centered on it.
That's the same sort of thing self-driving cars do when they are looking for lanes.
Yeah.
Lane markers, right?
So if you just have one line, this works. For a self-driving car, what they're going to want to do is try to break down the line between the lanes. So like you can imagine there's an imaginary line that is formed by all the pixels within two lines on the outside of a lane. And then you would run the linear regression on that lane that's not there. You can't see normally with just colors. So it's kind of a two-level step. You have to figure out where that lane it begins and then find all the pixels in that and then run linear regression on that. But yes, very similar technique.
You just mentioned color. Is the OpenMV camera in color?
Yes. So our sensor, we're actually using a very cheap OmniVision sensor. It's a OV7725. It can do 640 by 480 at about 120 FPS, and we can actually achieve, depending on the algorithm, up to 90 FPS.
Is the frame rate more important than the pixel density for certain applications?
Yes, very much so. So really, you can get away with 80 by 60 pixels and 160 by 120 pixels for a lot of applications. Having more resolution doesn't benefit you at all, really. It just adds more processing time. The big thing resolution helps with is distance. So if you need to resolve smaller detail at a longer distance, that's where resolution helps. But if you're looking for large blobs or whatnot, it's completely useless.
It seemed like when we had Pentium 2s, anytime you talked about machine vision or computer vision, which were the early days then, it was all about lighting. It was about having a maximal amount of light. That doesn't seem to be as big a problem now.
That really is what's helped is the camera sensor technology. So, one thing to appreciate, while I say the OV7725 is a cheap sensor, it's got a whole processing engine in it that does stuff like gamma correction, that does color matrix transforms on it, that automatically boosts the contrast, that does auto exposure control, that's doing auto white balancing. So the sensor on board really fixes the pixels up dramatically compared to probably a CCD back in the day, which would just give you raw sensor readings that you had to correct yourself. And so it's these cameras are quite good.
So the camera's gotten smarter,
yeah.
And then the way we interact with it has gotten smarter.
Mm-hmm.
So less of your CPU is being spent just massaging the image into something you can start doing machine vision with.
Yes.
Okay.
But yeah, no, lighting still is important. So when you're trying to follow a line outdoors, you got to use, the reason I like linear regression is because it's somewhat of a lighting invariant algorithm. What I mean by that is all you need to do is detect some subset of pixels. You don't really have to detect a perfectly good, like there's blob tracking algorithms you can use where you try to detect blobs of pixels and follow those. But linear regression is a little bit more robust because even if there's about 20% noise of false detections, it can still handle that. It'll reject those outliers versus blob detection type techniques fail if there's too much noise.
So back to color, because that's going to come up with blob detection in a minute. When you do line following, do you bother with masking it so that you're only looking at a subset of colors? So if you're following a yellow line or a white line, you do some masking where you choose that color.
Yeah. So we actually have a function on the OpenMV It's called getRegression. And so you give it a list of color thresholds, and what it's going to do is it's going to threshold the image then with that list of color thresholds. So the color thresholds are like min and max of red, min and max of green, min and max of blue. We don't use red, green, and blue directly, though. We use something called the lab color space, which is lighting invariant, but it's still like a min and max of each channel. And then that basically gives you a binary image, which is just white or black pixels. And then the linear regression is run on all those pixels that are white in that image. But this function kind of does all those steps in one go. And that's one of the nice features of the OpenMV is that in an OpenCV world, you would actually be required to first binarize the image and then run the linear regression afterwards, making that 2 steps. That doesn't sound that bad, but for other algorithms like line detection, you have to, let me think, you got to do Sobel image filtering first to get like straight lines in the image, and then you have to hit that with a Huff detection, and then you get like this map of this 2D accumulator map that tells you, what the strongest lines are, and then you got to find those strongest lines, and then you got to take that and do this other step, and just lots of different steps. And I kind of package things like that into one function call where it just kind of gives you the result you care about. It does mean you do learn less about how these things work, but most of our customers kind of just want to build something, not get the PhD.
It's still a good starting point. I mean, do you talk about how those things work in documentation or
I wish I had time.
Yeah.
It's right now, the product is new, so it's mainly just people are asking for features, all my time is spent implementing them. But as the product gets more mature, we're going to have more time to come back and actually talk about that.
So you're trying to build up a library of, these are the kinds of things that people want to do with machine vision. And so here is the function that does that. Whether or not it takes 5 or 2 or 18 steps, I'm going to pick the.
The idea is really what I want to do is for every function call, they more or less take the image and then output some list of objects that are the results you want. Okay. So for QR code detection, the QR code detection library has a ridiculous number of steps. It does all kinds of crazy things to find QR codes. But from your point of view, all it does is you call it, and then it returns to you a list of QR code objects that are in the image. You don't have to worry about all the machine vision that went on in the background to actually make that list of objects. Also, the big thing is because we're on a microcontroller, we only really have one frame buffer. So if we had to edit the image to do that detection, it would kind of ruin the experience. So what we do is we create a second copy in a temporary RAM space that we have, and we can do all the machine vision processing there. And then we just return the results to you. And then you can edit the main image and draw like boxes on the QR codes.
You mentioned Arduino, and I can see how that is a good comparison, because to run a servo motor in Arduino, you basically just set up the servo library. You don't worry about whether or not you have to do PWM or I2C to another device. And you just move the motor.
Yeah.
And that's what you want to do. You just want to follow the line. Show me where the line is. Don't make me do all of these other things. On the other hand, once you've done that and it doesn't work the way you want, people often want to dig in. And some of that is learning about these things that you were saying.
Well, you can. So all our firmware is open source. Everything is in C, and you can go online and download our compile toolchain. We actually just use GCC, totally free compiler setup, no Keel tools. I think that's how you pronounce it, Keel.
No one knows.
We say Kyle, but Keel seems very reasonable as well. Kale would also be fine.
Kale. I want some of that.
Let's just call it Kale.
Well, it's GCC, so it's free. It's not $10,000 to get access to the compiler.
Right.
Yeah.
And we actually, our OpenMV has a built-in USB DFU bootloader, and our toolchain actually comes with scripts to be able to reflash your OpenMV camera using that. So you can download our build system very easily. We have a web page, a wiki page describing exactly how to install it and everything, very detailed. And from that, you can download the C code and edit, add new algorithms. If you want new features in the Python level, you can add them. If you want to change the firmware and how it works, you can do it. It's your platform. You can go ahead and edit anything you feel like.
So this is a microcontroller that is running a MicroPython interpreter with additions for for camera vision, but it is written in C.
Yes.
Okay.
So the OpenMV is actually, I want to give some credit to Damien George. It's really his MicroPython is what's making this all possible, and really my vision possible with this. So MicroPython, if you haven't heard about it, is a operating system. Well, I wouldn't call it that.
Interpreter?
It's an environment that runs on a microcontroller. Basically, it more or less lets you write Python code that gets compiled, turned into a byte code. So it's the system isn't reparsing text constantly. It's looking at byte code, and that byte code pretty much become like pointers to a bunch of statically linked C file. Well, all the code in C. Okay, I'm going into too much detail. But anyway,
no, it's good. It's good.
It's good. Okay.
They can take it.
So
I know at least one person who would be interested in this.
Okay. So
Yes.
your byte code is being executed by some kind of virtual machine.
Right.
And that virtual machine, when it sees like a byte that specifies this function call, it will go off into the C code and basically convert all your Python objects as the function call arguments into C arguments, and then call a C function, and then bam, you're in Seaworld. The user doesn't see this though, but from what's being actually executed, you're in Seaworld, and bam, things just execute like they were in C. One really nice thing though about MicroPython is because you have this decoupling between the C land and user space, you don't have to follow standard C cleanup procedures for malloc failing. For example, in OpenMV code, we basically just set jump. We'll throw an exception every time we run out of memory or anything bad happens. And this makes our C code rather easy to write since we don't have to clean up ever. This is because MicroPython has an exception system built in. So if any function fails to allocate memory, because let's say you want to find QR codes in a 640 by 480 image. Well, we don't have the RAM. Our library code is written to, as it has more RAM available in the system, it'll just work. So you could actually use our code on a desktop computer and it would be totally fine. Anyway, so if we don't have enough RAM, we just throw an exception saying we're out of memory. And this allows us to write really straightforward C code that doesn't have a lot of cleanup. But in user space land, we don't actually leak memory because Python has a virtual machine that's doing garbage collection for you. So if you, like in C land, if I do a malloc and then I have to throw an exception to get out of there, I just leave that memory lying around and it gets cleaned up by the garbage collector whenever you're out of RAM.
That seems sort of magical. And yet this is a capable enough processor that, yes, you can have that overhead. Mm-hmm. And Python is so much easier to use at this level. Mm-hmm. So there's MicroPython, which is a thing. Mm-hmm. And there's OpenCV, which I've used in Python, but your device does not use OpenCV.
Yes. It would have been lovely to be able to do that, but OpenCV does not respect memory too well. An example would be, so a lot of times I'll download code and you'll find things like, let's say there's an image that is only storing values that are maybe between 0 and 20. Like that's just the terms of different values. But they'll use doubles instead of a byte. Right. And so you find abuses like that all over OpenCV, or they'll just assume the stack is infinite and they'll just allocate 3 or 4 megabytes on the stack just randomly, or you'll find things like I ported the April tags algorithm actually to the OpenMV cam, and this was it took me about a week of effort because the library was written for C, for a desktop computer. But I have to say, I met the guys who created that in person, and because they were impressed by me doing that porting, and in fact, getting it to run on such a low-level embedded system, because that was kind of their goal on simplifying their algorithm. But a few of the things I found in there were they wanted O of n1 time to access a hash table. Well, sorry, let me back up. Basically, when you're doing April tags are these QR code looking things. You might have seen them on Boston Dynamics robots.
Oh, yeah, okay.
They look like giant low resolution QR codes. So one of the tasks, after you detected one and you have the bit pattern, what they do is they have this huge lookup table that's about, let's say, 512 patterns. And what they'll do is basically you're supposed to linearly search through the lookup table and compare the bit pattern you have to the bit patterns in that table. And what you're doing is a Hamming distance, so you XOR all the bits together from each detection, and then count the number of ones, and that's how far away you are from that code, and you find the one at the lowest distance. And that's most likely the code you're looking at. And that works really well. But, they decided, we got to make this better.
Make a jump table.
Yeah, no. So what they do is they compute every possible bit pattern that's off by 1 bit, off by 2 bits, and that uses 20 to 30 megabytes of RAM. Now it has O of 1 time though.
Oh yeah, that would be super fast.
But here's the thing: it barely matters though, because most of the work is spent detecting where the QR codes are. Very little time is actually spent searching through that table.
Oh wow! See, this is a good example of improper optimization. Yeah. You're not optimizing the thing that takes a long time. You're optimizing the thing that's fun to optimize. Yeah.
Well, I don't know. Maybe their application, so they're using a desktop class computer with lots of memory, and they can handle a lot more, a larger image. And so with more resolution, they can see farther. So it's possible they could have seen maybe 40 tags in the field of view. But still then, they're allocating 40 megabytes or so, for just this lookup table so they can do O of 1 access. And that's only 2 Hamming code bits off. So you could go to 3. Or you could go to 4. Sometimes you could go to 5. How far do you want to go?
I mean, if you have enough memory, it doesn't matter, yes. Right? I mean, I've done things like that for, quote, embedded systems where I was on a PC platform. It's like, oh, well, this would go a lot faster if I just grabbed a gig of memory and made a gigantic lookup table. And I did that because I could. But those are the things people don't think about. If they're trying to make something that's generalizable to all sorts of platforms, it's a very difficult problem.
Yeah. It's really surprising that since I was able to get April tags running on the system, I'm not really that concerned about its capabilities anymore. I mean, we've got the ZBAR library running on it. We've got something called libdmtx, which is for data matrix detection, April tags, QR code detection. All of these are, people would consider very high-level machine vision things that couldn't run on a microcontroller. Totally impossible. And yet here we have them running on the system, and it didn't require that much work.
Okay, so I'm picking up the system. It is much smaller than palm size. So pretty small. And it's got the camera, which is pretty obvious, and it's on a board, which isn't very big, but it's got stackable shields. Yeah.
So that was Ibrahim, my co-founder's great idea. This is part of why. So by the way, the OpenMV cam is his baby. I kind of joined on to make it a commercial success, and I guess it's become my baby since I've been working on it for 2 years now. But what really struck me about the idea was pretty much he had so many good things in one package. The idea was, okay, we've got this MicroPython environment, which really simplifies how to deal with machine vision. And then we've got this stackable shield setup where you can basically, we've got this, form factor where you can just add new modules to it. And stuff like we used to have, for example, a thermal sensor that could do a 16 by 4 pixel resolution to do thermal imaging pretty much. That wasn't really that sellable though, because when you worked out the math for what the price it needed to be like $150.
Yeah, thermal sensors are.
To keep the company in business if we were selling it, and that's kind of beyond the price anyone wants to pay. But, the idea is that you can add like for example, we could have a shield that had a spy camera on it, and you could have 2 cameras. We have an LCD shield you can put on the back, and then you can see what the camera sees as it's moving
really
around.
Cool. I liked that.
And it updates fast too. It can do about 30 FPS on the LCD shield.
This middle one has some sort of
Wi-Fi.
Oh, I was going to say it has an antenna on it. Okay, so that's Wi-Fi.
Yeah. So our Wi-Fi support is okay right now. Our next update, though, is going to enable Wi-Fi programming. What I mean by that is literally you'll be able to connect to the system like if it was attached via USB over Wi-Fi. We've got so what really makes the OpenMVCam go besides all those things is the fact that we provide you a good computer development environment. We have an IDE which kind of smooths over all the uglies to interfacing with this system and programming it pretty much.
And it runs on PC or Linux or Mac.
And it's going to be Raspberry Pi soon also because folks have asked for that.
And I can type in my algorithm, I can test it, and then I can take it off of my computer and it can run on its own.
Yes. So the IDE basically gives you a little frame buffer so you can see what the camera sees as you go, and it's pretty much, real time. And you just write some Python code and then literally just hit the run button, and that's the compile, load time, execute, all less than a second, and your algorithm is up and going. And when you want to kill it, you just hit the stop button, and it dies.
So that, again, is like Arduino, where you kind of play with it, and then you walk away. You don't have to have it connected to the computer.
Mm-hmm.
And this runs on 5 volts, so it will run just on USB, right?
Yeah. So the microcontroller is a STM32 microcontroller, and what's really nice about those guys is they have 5-volt IOs, 5-volt tolerant IOs.
Yeah.
And well, they're 3-volt IOs, but they're 5-volt tolerant, meaning that you can totally just plug it into Arduino and nothing blows up.
Yay!
And, it's surprising. No, people don't normally comment on that, but, you really got to understand that a lot of folks immediately plug this into an Arduino and don't think about the fact that, this would normally break terribly. But with this STM microcontroller, it's totally cool.
The top shield on this one that I'm holding, is it a PWM shield?
So it's a servo controller.
Servo controller.
So the OpenMVCam, since it's powered by STM microcontroller, it obviously has the ability to do PWM, SPI, I2C, interrupts on I/O pins. It's got a DAC and ADC pin where it can do DAC and ADC functions. It's got servo outputs. It's got PWM and a few pins. It can do all that stuff. The problem is the processor usually gets busy, so refreshing all the time is a little bit tricky. A lot of that's handled via interrupts to keep the servos being refreshed. But when you add USB on top of that, when it's plugged into your computer, the USB kind of has the highest priority because it needs to be serviced. So when it's plugged into your computer, the IOs kind of are a little bit wonky sometimes. You're trying to push things real hard. So it's better if you just kind of attach things that are bus-based to it where it doesn't have to manually refresh everything constantly.
Well, one of the advantages to having an external servo chip is the ability to run it at a higher voltage. I mean, motors don't usually run at 3 volts. And if you try to run a bunch of motors from your 5-volt USB, I hope you didn't really like your computer that much.
Well, yeah, that's one of the benefits here. The Servo Shield also has a nice little feature in that the VN rail is actually shared on it. So with using the Servo Shield, what we found is you can plug this directly into a RC car that has like an ESC, and those ESC controllers, electronic speed control, I think that's what they're called. Yeah. They actually output voltage instead of taking it. So literally, you just plug one of those servo lines into the servo controller shield, and bam, it powers the whole system. And then you just plug in your steering servo, and you're good to go. You've got your robot that can see now.
That makes it so much simpler. I mean, that's really powerful.
It's more it seems like almost a robot platform.
Mm-hmm. It seems very much like a robot platform.
Have you considered renaming it?
When I first saw it, I thought it was a smart camera. And since I've been working on a robot, and since my robot has this massive controller, I was thinking, oh, it's a smart camera. These are the things I can do with it. But it wasn't until I read more and spoke with you a little bit that I understood it's the controller. I mean, it can be a smart camera, but it makes more sense as the brains of the whole outfit. Yes.
So a lot of folks actually ask us about that. They want to use it as a smart camera, and I'm kind of flabbergasted a little bit by that.
I spend a lot of time in Python OpenMV on the Jetson, and it's sort of amusing, but it's kind of annoying. I wish I could just say, find the laser, or find the blob, or find the line.
Well, a big thing is, do you have examples to work with?
Sure, I have all of OpenMV examples to work with. It's kind of daunting.
But they are installed for you?
A lot of them, yeah.
Okay.
Well, because, the Jetson is not an embedded system. Yeah. They say it is an embedded system, but it's crazy. So it's more like having a PC.
Okay. So what we do for OpenMVCam is we got the Arduino-style example set up. Literally, there's a folder, you click examples, and it just has like 80 examples.
Yeah.
And the examples just show off the machine vision algorithms in a kind of stupid script. Like, here's the color detection one. You just point it at colored objects, and it tells you where they are. And it's literally 5 seconds of effort, and bam, you technically have your machine vision component part done. Then all you've got to do is write up the Python code to control things, and you're good to go.
It's so amazing.
When did you make a decision to say we need to build an IDE? Was that always part of the plan? Or
it was Ibrahim's original thing. The reason, Ibrahim put this project up. Again, Ibrahim is my co-founder. He's not available today though because he's in Egypt. That's where he lives. Anyway, but it was his idea to put the IDE in the first place. Like, I would have ignored the project and just said, this is... so again, let me back up. I found his project on Hackaday. I was bored one day and was just looking through Hackaday articles. And
that's dangerous.
well, Hackaday.io.
Yes.
Yes.
And everybody puts their projects up, and then it goes from being a mysterious, faceless widget to being a person creating things that you want to help.
Yeah.
Yeah, and so you wanted to help, and here you are.
Yes. It's been an odyssey. So he started the project. Basically, we linked to his first blog post back in 2013. It's on our About page on our website. He pretty much wanted to create a better camera module. So a little bit of history about me first before I go into this story. I did something called the CMUCam 4 back in college at Carnegie Mellon. This was so a lot of people have heard of the CMUCam.
Yeah, I think I heard of it when I was doing some stuff.
It probably just didn't sync up at the right time for me.
Okay.
But he's heard of it.
The CMUCam has been around since about 2002, and it was created by my research professor, Anthony Rowe. And, it wasn't created by him. It was created by a guy named Ilya Norgrush. I can't pronounce his name. It's a little bit hard. But he had Anthony Rowe build this little cheap camera module. And it was cheap in the sense that it costed only $150 back in 2002. And it could had a really bad camera sensor, not very good at all, but it could see colored objects. And it was the first time anyone with a microcontroller platform, and this is before Arduino, back in the basic stamp era, had been able to, actually have a microcontroller that could see anything. And there was a CMUCam 2 that followed on and was very popular in first robotics. And then a CMUCam 3 where the CMUCam 3 was actually quite similar to the OpenMV Cam. It could do Lua scripts. It had a little editor. It had the ability to detect faces. It had an SD card. A lot of similar features. However, it had one bad problem. It costed $300. And so that could have been a really popular system, but it was too expensive because back in that time, you couldn't make it cheap enough. In particular, the problem was it had to have a FIFO buffer memory to store the image. And these FIFO buffers costed an arm and a leg. You can still see them around. They're like these weird FIFO memory chips that can store like 1 megabyte or something, but they're super expensive. Anyway, so I was when I was an undergraduate back in school, I started working on something called the CMUCam 4, and this was a successor to the CMUCam 1. Effectively, it had it was about $100, $99, and it had a propeller chip on it, and it could look at a 160 by 120 image and track one colored object. It wasn't very powerful, but it had no bugs. No one ever put a bug on me in terms of the firmware being broken. However, also people barely knew how to use it though, because by that time, education level for people actually being willing to read the manual had gone down to epic low levels at that point. I think it's always been that way. I learned never. So here's a tip. Don't ever write a PDF and put it online. Just make a web page.
Yes.
People don't read PDFs. I really wish they did, but they don't. Especially a lot of customers or a lot of our customers don't speak English. They can't, do Google Translate on the PDF. So put your documentation online.
The last time we, sort of gave up on everything was when we tried to name everything README, as if to encourage people to read things. When that didn't work, I think we all just gave up.
I read things.
You
I
are a
haven't read
minority.
PDFs. I know, I'm a minority. Okay. So CMUCam 4.
Yeah. So let me continue. I'll get to the. I'm a long-winded person. Okay, so that system could track one color, and it did it really well. It did 30 FPS fixed. We only sold about 1,500 lifetime, but yay, it worked out great. I learned a lot of stuff from doing that. And so here comes Ibrahim in 2013, and he saw my project and he said, I like it, but it's expensive. I want to make it cheaper. That's always the goal of a hobbyist. How can you make this cost $20 and not have any money off of it to actually build a second one? But he wanted to make a cheap system that can do computer vision, but could be programmed pretty much. Like the CMUCam is a fixed function device. You bought it, it did its thing. You talked to it via serial. You didn't ever reprogram it really. And so his system was using a much stronger processor, could actually do more than just color detection, could do face detection because now it could store the image in RAM since it had around 256 kilobytes of RAM. And that's what I saw on Hackaday. I saw that platform. And I saw another big thing was he had put together a Python IDE. It kind of had a lot of problems. We never really fixed that. We kind of moved to Qt because I was an IDE developer in that and I could do a good job.
Good choice.
Well, it was surprisingly, Python is great to write an IDE in if you don't feel like having any users. If it's just you. No, I got to be serious. So one of the things you got to think about if you're writing software
for other people,
yes, is how to deploy it, because these things ruin you. libUSB, I want to say I like that library. It was really good for getting OpenMV working initially, but you can't deploy it. Getting it to run on Mac or getting it to run on Windows is a nightmare. Just absolutely a nightmare. And one of the big problems is that you need to have signed Windows drivers and not like the easy .inf Windows drivers. You need to have like actual code executed. And so this requires a big, scary amount of Windows certification on your part.
It's expensive.
Yes.
Yeah.
For example, you have to buy these things called digital verification. I forget the name of it, DigiCerts or something. But they cost, you have to actually get a hardware dongle key that plugs into your computer. Like they're really serious about this kind of stuff, and you're going to end up paying around $1,000 to $4,000 to get it because you're programming software that's going to install a driver into the kernel. So they want to make sure you're doing doing the correct thing, and that's the kind of stuff you might run into if you're using libUSB. So if you're a hobbyist or someone who's trying to bootstrap a company with no money, that's kind of a little bit unpalatable.
But cute or QT as people say it incorrectly.
Yes.
As I always say it, it's cross-platform.
Yes.
And it makes this so much easier.
Yeah. In particular, it has a cross-platform serial port driver for you, which we were able to switch. So like what we did was our OpenMV library was originally written for libUSB, and then we basically stuck that onto a generic virtual serial port driver. And then because of that, it looks like a serial port when you connect it to anyone's computer. And then we were able to use that with Qt to create a, to basically talks to it like if it was a serial port pretty much.
Sure, that makes sense. Okay, so that ended up building an IDE, which is what I can program into, which is much easier to use. As we were talking about, it's sort of like the Arduino one where it's kind of simplifies it all.
I say that's important because if you look at MicroPython right now, so the guys who are maintaining it done a great job. They, though, believe that people want to use RELP to program it with, and I'm not sure if that's correct.
RELP? I mean, this sounds like something Scooby-Doo would say.
Well, maybe that's not. I'm probably pronouncing it right. It's the read, evaluate, print loop. So REPL. REPL is the better.
Oh, okay. Yes.
Yeah, I'm pronouncing it wrong.
We're going to have to flip it around so it's the other way, though. I like it better.
RELP. Yeah, I just make up words when I see it, and then that's
fine.
How I think about it.
Okay, yes.
Okay.
They think you want to type into it all the time.
Yeah, but a lot of the examples they show are like, hey, you can type into it and program it via that way, and that's cool. But that doesn't scale beyond the example of showing people that it's cool.
No, that means I can do it, but I can't ship it to other people.
Yeah.
Okay.
But no, I mean, like literally, it's you program in a line, and then you have to program in another line, and you can't go back to the previous line.
Right.
You just program in one line at a time. So that really doesn't scale to you writing a huge program that's 200 lines or 1,000 lines if you need to. You need
Gives
to
you
have
that nostalgic feeling for 1980.
Yeah.
Which really wasn't what I wanted to do with my life anyway.
Well, see, here's the alternative. They have such you can save a file to the system and it'll execute it. But the problem with that is you have no way of knowing if your file had a compiler until you execute it.
Whoops.
And you can get that result then on the serial port. But having the editor, we're able to send the file to the camera. It does the compile and then spits back out if an error occurred. Our IDE parses the text message to find the error and then literally opens the file with the error, highlights the line, and then says what the error is of a little dialog box. Just like an Arduino, even better, it tells you exactly what line of code you have a problem on, which makes your development experience a lot simpler.
So much better.
Mm-hmm.
Okay, so I want to go back to my idea of if I was using this.
Okay.
I did some laser chasing so that my robot would follow a laser around. Mm-hmm. And how would I do that on OpenMV?
Okay, so our biggest feature, I think, which has helped sales the most is color tracking. That's what a lot of folks...
Which you've been doing for a long time?
Yes. Okay. I've been doing that for a long time. That's what most of these camera systems have been doing. So we've got that. We have a method. I got to call it method because, it's bound to an object. It's not a function, which doesn't... Anyway.
You
can use whatever words you want.
Whatever words I want. We got a thingy that...
A subroutine.
Subroutine. Go sub.
Yeah.
No, so we've got a method called find blobs. And basically you give this a list of colors that you want it to track, the color thresholds. And those thresholds are, again, min and max of basically like YUV, min and max of lighting, and then min and max of the color channels. And in order to find those, by the way, we realize it's hard to find those values.
Yeah.
So we have a built-in slider.
Oh, nice.
So you can basically, in our image, you can click a button and it'll show you a picture. It'll capture a frame from the camera and show you a picture of that image, one with the actual picture and then one of a black and white image that's of the thresholded pixels. And then there's 6 sliders, and you just drag the sliders around until you have just the pixels you want to actually track.
In OpenCV, they take HSV, hue saturation value. Mm-hmm. And with red, it's kind of hard because it's on the edge of a discontinuity. Mm-hmm. So you have to do both sides. And if you're doing min and max, then that totally breaks min and max if you're around a discontinuity. And it's super annoying. And that sounds so much better because I always knew what I wanted to find, but I couldn't necessarily translate that into all the things until I tried. I mean, I must have tried like 25 different options.
Yeah. That's our goal, is to save you time. That's like why anyone would buy our system, because it's not the most powerful, certainly, but it's hopefully the most easy to use. Obviously, you can't infinitely scale it for every application, but the idea is for most people, it'll do the job you want.
Okay, so find blob on color.
So find blob on color. And by the way, if you have that discontinuity, it's a mouthful. Anyway, if you've got that word, you can track 2 colors or 3 or 4 thresholds at the same time. So you just input the color thresholds that you want for one part and then the color thresholds you want for the second part. And you can pass the function a parameter called merge blobs, and it'll literally merge those detections that it sees that are next to each other into one color blob for you. Anyway, and so what that will return then is a list of blob objects. So there's a Python list. You can do for b in list or whatever, and that's your blob. So simple Python iteration. And each of those blobs then encodes the centroid, which is the center position of the pixels in the blob, the min and max bounding box around it. So this is like the box that surrounds it. We also compute the linear regression on the blob, and this returns basically an angle. So if the blob is like a pencil, it'll actually tell you the rotation of the blob. And we also compute the number of pixels. Well, obviously, we count the number of pixels in the blob so you know how many pixels it is. And that's useful for density checks. So if you do things like divide the number of pixels by the size of the blob, that'll tell you how dense it is. And a density then usually is a good detection. Like basically, if you're looking for like a round object, the density should be rather high all the time. And if it's not, then it's probably not the thing you're looking for.
Well, and for me, for laser chasing, if I had a round object with a good high density, I could have something in the same color space that was a reflection of my laser to another part of the wall. And that would be much less dense and maybe not the right shape. It would have fewer pixels. It would be less dense. It would be the wrong shape. And so I could eliminate that.
Yeah. Yeah, that's one of the big things, and that's what's really powerful about the OpenMVCam is because we return to you blob objects, and because you're in Python, you can filter and sort things. Actual computer programming, you can do that on the system, because this is where things usually break down with doing like computer vision on microcontroller or Arduino is you can't manipulate things. It's just too hard in C and see, I'm getting like really animated right now because this is really the important thing to understand is because you're in Python, you can sort objects, you can filter objects, you can decide I want to look for the maximum object that has the most pixels set inside of it, and it's one line of code versus being some weird function call where you've got to set flags and other things and makes your life harder.
And you can do things with it. I mean, once you find the centroid, you can say PWM my motor to here, or there's
so we have a servo.
Do things like inverse kinematics and other things that are mathy.
Yeah, you can. So the thing has a double precision floating point unit, so you can use doubles. So let me back up. You can use doubles in C land. You can't use them inside of MicroPython because everything's afloat. But in terms of that, we actually have hyperbolic tangent support. There's basically every single complex and non-complex, and by complex I mean like, A plus IJ or something. You have all those math functions. So you've got the full desktop library of actual math functions to work with. And you can have scripts that are thousands of lines of code. Of course, there is a limit on your script size does get compiled into a bytecode object, and that bytecode object does get stored on the heap. So there is, a practical limit on how...
It's not infinite.
Yes, it's not infinite.
It's big, but not infinite.
Yes.
Okay.
But yes, you could do inverse kinematics if you wanted. And if you found that, hey, you wanted to actually support the project, you could then submit us a library that was written in C for inverse kinematics, and then we could put it in the firmware. And then that code cost wouldn't be something you'd be incurring in Python. Well, it wouldn't cost you anything in Python land then.
Well, and you said faster. I could recompile. I mean, I don't have to submit it to you right away. I can do this myself if that's what I want.
Yeah, all you need is a Linux system. The only problem, so here's one thing that's also important to appreciate between C and Python world. Our firmware image is about 1.5 megabytes right now. Okay.
How big is your chip?
It's a 2 megabyte flash.
I see. Okay.
But this is ARM thumb. Okay, so a lot of people will look at and see the expressive chip and see that it has like an 8 megabyte chip in there. You got to understand though, it's using 32-bit instructions and they aren't as optimized as ARM instructions. So like the same flash goes a lot less over there.
Well, that's a good point.
Yeah, ARM's, because we can build shifts into every instruction with the ARM processor. But well, anyway, my goal in saying that was it takes a long time to program in C. So if you're going to go in C land, just be prepared that this is actually, you'll be in the area where this is actually how long it takes to program these systems in the real world, and you'll appreciate the difference then.
You're still loading firmware over the serial USB bootloader. You're not JTagging it in through a programmer.
So we have two methods. We actually have a built-in USB bootloader that allows us to reprogram, and it goes quite quickly. It'll erase the memory in about 10 seconds and then write 64-byte chunks repeatedly to fill the image up. The thing is, though, that still takes on the order of about a minute to program. And, that's what you incur every time you want to recompile and change anything in C-land, even if you're running with our build system. So, me and Ibrahim, we suffer so that you don't have to.
You guys think that's long? Oh, man. I'd kill for a minute download times.
But your other programming method is through a JTAG?
So we have the SWD pins exposed.
Yeah.
So you actually have full ARM debugger support.
Okay, good.
So, I mean, with our system, the OpenMVCam, we have the SWD debugger pins exposed. If you are a real professional and you know how to use those tools, you can totally be in C-land, work with the system in C-land, and hook up a USB debugger to the system, reflash it through that, do breakpoints, whatever. It's fine.
It's good to know. I mean, because sometimes, I guess one of my fears with going with OpenMV for a professional situation would be, what if it did 95% of what I wanted, and the last 5% was somehow impossible given the current constraints? And knowing that I could reprogram it, that I could do modifications, I could tweak what I needed is important. But that brings me to my other question, which is probably a whole nother show, really. How do I learn enough about computer vision topics to be able to go beyond the surface of OpenMV?
Yeah, that is something I don't know how to solve, and I really wish I did. Pretty much, I guess what I'm trying to do is just make you can't fail type of applications available for the system. Like if you want to do barcode detection, our feature on the system for that is kind of a can't fail level. It would be hard to build a system where the function did not work, as long as you got the focus right on the camera for like looking at the barcode. Otherwise, it's stupid simple. For actually doing really more complicated things, our goal is really to try to hide complexity as much as possible to give you the highest level feature you want. So I recently found out, for example, that Google has something called MobileNets, which are a Google machine learning. These are a neural network that Google has trained that fit on your phone. And the smallest of them, which has the worst accuracy, that said, but the smallest of them can actually fit on the OpenMVCam's flash. And so it is possible in the future to give this system a neural network. Now, it would have incredibly terrible performance. It would be basically only 60% right in the top 5 categories, as in, if you pointed at an object, 60% of the time it would have one of the values in the top 5 things it thought the thing was be the correct object. But it's still possible. I'm not sure if that performance increases if there's only one object in the field of view versus a bunch of different things. But that'd be the kind of thing we want to integrate onto the system. And so you wouldn't have to learn about how neural networks work. We would just have a function called find stuff. And you would point it at stuff, and then it would tell you what stuff is.
I like that, but how did you learn how to do the computer vision stuff?
Yeah, that's what OpenMVCam is teaching me.
Oh, I see. I see.
This is how I'm doing my graduate degree in computer vision.
All right. I understand that. I do. I really do.
Yeah, if you really want to learn more about computer vision, I guess the thing to do would be to actually... Okay, so I've learned a lot of stuff from reading through other people's code. If you read through the C codes, the C library that we actually use to do a lot of the stuff, in particular the April tags function, it is ghastly scary, though. It's 15K, just one file of code. That was actually on purpose. So we have a lot of different things we're incorporating into our library.
About to start code reviewing you.
Yeah. So I actually manually took the April tags library when it's distributed, comes into about like 60 different files. And I took that and then merged it all into one big file. And that was to simplify our end, because on our library, we have a bunch of different files then, and we didn't want a huge library floating around in there. But if you look through that code, it spans everything from doing the basic image operations to very, very high-level math and matrix operations. Like doing matrix stuff, then that's way beyond my level, is really a huge bulk of where you get into really advanced things, like being able to not invert matrices, but single vector decomposition.
SVD, yeah.
Yes. I do not know what that's useful for. I'm not that smart. I really wish so. But I should study it, I hope.
It's pretty cool. And I actually have a website I love sending people to, so I will put that in the show notes about singular value decomposition and how useful it is.
They've got even more. There's actually, in the April tags code, there's pretty much a complete... there's a complete library for every matrix equation you want to do in that code, because what they're doing is when they detect a tag, the tag is kind of like rotated in 3D space,
right.
And so they have to undo that rotation.
And that's all matrix math.
Yes, it's all matrix math.
And it's neat math. And yet I want to say that's not computer vision.
But that is computer vision.
But it is computer vision. It really, really is. And I have been learning stuff by reading the OpenMV PDF manual, which comes in a web page as well. But I don't like web pages. I like PDFs. And that has been helpful because I can try stuff and use it. But it also is huge, and I don't feel like I'm ever doing it right. I'm just following examples. So at some point, somebody's going to tell me how to learn all of the computer vision, preferably overnight, matrix style.
Well, I think, have you seen PyImageSearch?
No.
You haven't? Okay, PyImageSearch is this website that just goes through how to do OpenCV stuff, and they're really good with teaching you how algorithms work and doing step-by-step. A difference between me and them would be in PyImageSearch, they're trying to actually help you understand what's going on versus I'm just trying to give you the easy, I want to do something, I don't care.
Sometimes you need one of each.
Yes.
I mean, usually, and I suppose it's PyImageSearch, and it's not that you're searching for yummy raspberry
that's
pies.
what I meant. I meant the pie is in...
Oh, no, I got it eventually. I just was, I guess I'm focused on pie and not the right kind. Okay, one more question. I'm sorry, this is going to be a little short. We have a couple other things we have to do today, but have you tried using this in stereo?
In stereo? Yeah, we're actually looking to build a product we were thinking of, which would just be like a giant PCB that would have nothing on it, where you just mount two cameras side by side, and there you go. That'd be a stereo camera. We never got around to building it, though. Ibrahim's done some prototypes on it. It just hasn't been a priority, but it is something we could do, and you'd have one camera as like a master, which would request a second camera to give it an image, and then that master camera then would actually be able to find which pixels were out of alignment with the slave camera.
Yeah, the secondary camera, you wouldn't have to have it be as fast or as accurate since you're looking at probably close-up stuff. It doesn't have to be as granular. I mean, as you were saying, what you need resolution for is far-away things.
Yes.
And you don't do stereo on far-away things at that point. You don't, it's not useful.
Well, we also looked into what we really wanted to do was build a time-of-flight camera. So
yes,
there are folks like TI, for example, was selling a time-of-flight image sensor, and it literally was a SPY bus based, single bit SPY. It would do about 80 by 60 pixels, and you would just literally, tell it take a picture and then use the SPY bus to read image data off it. And we actually built a shield for the OpenMV cam, and we tried to get that to work. The big problem was those sensors need like 4 to 5 amps of current. Not the sensor, but they need they need a LED flash array, and you need like 4 to 5 amps of current to get that to work. And suddenly, that's no longer. I can plug this into my USB port safely.
Right.
Okay, so I'm interested in stereo, although maybe I need to play with it myself. And I am getting one of these, right? Okay. I know you're not leaving that one, but well, we'll see if you leave here with that.
I could leave it.
How much are they? And where can people get them and all of that?
Okay, so they're $65 right now, the current version. This is the M7 version.
You had some older ones for a little cheaper.
Yes, those are gone now.
Oh, okay. So M7, $65. Cool.
Yes. We want to get the price down to about $45. That's our target. Our current production run capacity is about 2,500, and so our next production run we want to do on the order of 3,000 to 3,500. And I think once we break the 5,000 unit build, we'll be able to actually sell these guys at $45 each.
How exciting.
We also plan to offer a higher end system at a higher price than kind of have two market segments. But at least for now, our goal is to really just up the production quantity of the M7 and make it cheaper and cheaper so everyone can get one. And they're available on our website. We just got 1,000 back from the factory, and we're waiting for our 1,500 more.
That's openmv.io. And of course, that link will be in the show notes. But they're also on
SparkFun. We have a whole bunch of distributors. SparkFun bought 500 cameras.
Oh, how exciting.
They really believe in the product. They actually moved 200 like in 10 days when they first put them on their website. And so they got 500 more. We've got a bunch of other distributors like Seed.
And Tindy.
Yes, I think someone was selling them on Tindy.
Okay.
We've also got Chinese counterfeiters. Those are on our website too.
Well, and you have...
We link to them.
Great.
That's one way to deal with it, I guess.
I mean, your boards have the Open Source Hardware Association logo. It's open source hardware.
Yes.
So are they really counterfeiters?
So you are allowed to make the software open source. However, the counterfeiters, I want to say, don't contribute necessarily. Well, one of them does. We came to an agreement to give some money back to the company so we can continue software development. We're fine if you building the system yourself. The big thing for us is you selling them and then us having to service people.
Yeah. Supporting the people who aren't supporting you.
Yes, so that often happens is we'll get boards come out and then people have problems and they didn't actually buy them from us, but we're answering questions.
Yeah. And that's a good way to kill a small business because it just sucks all the time and you can't do that.
Yeah.
But for all that this is a small business and getting bigger and you're spending a lot of time on it, this isn't your day job. This is a side gig?
Yeah. I don't have a girlfriend, so I have free time, I guess. That's sad. It's so sad. Anyway, no, I decided to pour all my effort into OpenMV. It's brought a lot of blessings to me in being able to meet people and help improve my life and so on and so forth. I found a lot of enjoyment through working on a project that has a particular goal in helping people. But it's a side job. It does not pay the bills. I have made probably negative money so far on OpenMV.
Did it help you get your current job?
Yes, it did, though.
Okay.
That's how it helped me get my current job in the Valley. I was able to meet people who helped put the connections in to get past the resume filters. And I had a thought there. A big thing with doing the OpenMV Cam is it's helped keep my skills current for my day job is a FPGA development, so it's Verilog, and your C skills, your Python skills, your
business management skills, your production skills. Yeah,
there's so many things that would kind of atrophy if I just was focusing on one language. That would be really bad. But for the OpenMV Cam, I've had to do stuff like I learned PHP to set up server scripts.
I'm sorry.
There were PHP scripts that were just copied from other examples, but do that. Learn how to set up a company, deal with LegalZoom, how to do bank accounts, what an ACH transfer is, learning how to do production runs, how to get distributors, how to actually
take
sell.
Credit cards.
Yeah, Shopify. That's the answer. But there's so many different things that you're able to work on and keep track of, and it's a nice learning experience running your own company. The trick is to never take money out of the company until it's ready. That's the big hard thing. Like OpenMV technically has some profits this year, but we have to spend all our money on another production run. So if you take any money out, you can't keep growing it. And that's one of the things you got to keep in mind if you're trying to do this kind of thing.
And that's hard because you do have a full-time job. This is essentially a hobby that sucks money, may someday make a little, but still at right now sucks money. It sucks time away from girlfriend, life, fun, probably even exercise and health to some extent. There's all these other things you have to balance in life. And yet when you talk about it, you're happy.
Yeah. And that's basically the way to say it. Yeah, it makes you it's your own little thing you can control. And you're kind of the director of the ship, and that's a nice experience. And also, it's nice that people want to talk to you and want to get you on their show and so on and so forth, because you're doing something. You're not sitting around at home. You're doing something that makes a difference in other people's lives.
Yeah. All right. I think this is a pretty good point to start winding up. Do you have any questions, Christopher?
I had deep questions about architecture, but I can ask him after.
Okay.
Fair enough. Kwabena, do you have any thoughts you'd like to leave us with?
Okay, it's been great being on Embedded FM. They have great microphones here. I was told to get a better microphone. But yeah, this is a great experience. I've enjoyed talking to you all. And I'll actually be at I'm going to be at the Open Source Hardware Conference later this year, and then at Hackaday Super Conference.
Yes.
Even more later this year. And I think I'm also going to be at the SparkFun ATV, Autonomous Vehicle Competition.
Well, that's great. We had Alan Yates on recently. He's going to the Supercon, Hackaday Supercon in Pasadena in mid-November. Open source hardware. I know we have lots of friends. We're actually sponsoring that and sending one person, and there'll be stickers in your goodie bag from Embedded FM. So cool. It sounds like those will all three will be fun places to meet you and say hello and get a look at this camera, which is pretty cool.
Okay.
Our guest has been Kwabena Agyeman, FPGA engineer at Planet. He is also the president and co-founder of OpenMV. If you'd like to buy an OpenMV or one of its nifty shields, really, look on openmv.io. A link will be in the show notes, of course. Thank you so much for being with us.
Thank you very much.
Thank you also to Christopher for producing and co-hosting. And of course, thank you for listening. I have said before, I think I said last time, I'm looking for a new gig, ideally something mathy or robotics-ish, maybe something that makes me learn all of this computer vision that I want to play with. If you know of somebody needing a strange set of embedded systems architecture, prototyping, code implementation, and personal communication skills, please keep me in mind. And now a quote to leave you with. This one from Maya Angelou. What you're supposed to do when you don't like a thing is change it. If you can't change it, change the way you think about it. Don't complain. Embedded is an independently produced radio show that focuses on the many aspects of engineering. It is a production of Logical Elegance, an embedded software consulting company in California. If there are advertisements in the show, we did not put them there and do not receive money from them. At this time, our sponsors are Logical Elegance and listeners like you.